Hey everyone, welcome back. In this chapter, we're looking at compressing and archiving files in Linux. This is something you'll use all the time when transferring scripts, backing up files, downloading tools, or creating forensic copies of storage devices. We'll cover archiving with tar, compressing files with gzip, bzip2, and compress, then finish with one of Linux's most powerful forensic tools, dd. Compression reduces the size of files, making them easier to store and transfer. There are two types of compression: lossy, smaller files but some data is permanently removed, and lossless. No data is lost. When extracted, the file is exactly the same as the original. For scripts, software, and documents, we always want lossless compression because we can't afford to lose any information. Before we start archiving and compressing files, let's create 3 simple shell scripts that we'll use throughout this chapter. So type nano cybered1.sh. This opens the nano text editor and creates our first shell script. Add the following. Save with Ctrl-O, press enter, and Ctrl-X. Now create the second script. Nano cybered2.sh. Add the following, save and exit. Create the third script, nano cybered3.sh. Add the following, save and exit. Now make the scripts executable. By default, new files aren't executable. The chmod plus x command adds execute permission so Linux knows these scripts can be run. Then verify everything with ls and use the L switch. This lists the file in long format, showing their permissions, ownership, size, and modification date. We should now see all 3 scripts listed. Notice the executable permissions shown by the X characters in the permissions column. That confirms they're ready to use. Now that we got 3 files to work with, let's combine them into a single archive using the tar command. So breakdown. Tar is the archive command. The C switch creates a new archive. The V switch, verbose mode, so Linux shows every file being added. The F switch specifies the archive file name. And cybered.tar, this is the name of the archive. Everything afterwards are the files being added. Now let's list the files inside the archive. This lets us look inside the archive without extracting it. So breakdown. The T switch, this lists the archive contents. The V switch displays detailed information. And the F switch reads from the archive file. Let's extract the archive. Type tar xvf cybered.tar. This extracts every file from the archive. The X switch extracts files. The V switch shows what's being extracted. And the F switch uses the specified archive. You can also extract silently. Type tar xf cybered.tar. This does exactly the same thing, but without displaying each extracted file. Okay, now we're gonna compress with gzip. Archiving combines files into one file. Compression then reduces its size. Type sudo gzip cybered.*. This compresses the archive using gnuzip. So breakdown. Sudo runs the command with administrator privileges, gzip, the compression program, cybered.*, the wildcard means any file beginning with CyberEd. The archive becomes cybered.tar.gz. Then verify it with ls and use the L switch. The file is now much smaller and has a tar.gz extension. Now decompress. Type gunzip cybered.*. This restores the archive back to its original .tar file. Now we'll be compressing with bzip2. bzip2 usually produces even smaller files than gzip, but takes longer. Type bzip2 cybered.*. This compresses the archive using the bzip2 algorithm. The extension becomes .tar.bz2. Verify it with ls and use the L switch. Then decompress it. Type bunzip2 cybered.*. This restores the archive back to a normal .tar file. So now we'll be compressing with compress. This is an older compression utility. It's faster but doesn't compress as well. Type compress CyberEd.*. This compresses the archive. The extension becomes .tar.z, and verify it with ls and use the else switch. Now decompress. Type uncompress CyberEd.*. This restores the archive back to its original tar file. The dd command is one of Linux's most powerful utilities. Unlike the cp command, which copies files normally, dd copies data bit by bit. It's widely used in digital forensics, backups, and disk imaging. So I'm going to create a small test file. This creates a small text file that we'll use to demonstrate the dd command. Now check the file. Type ls, use the else switch, demo.txt. This confirms our file exists and shows its size. Now we'll copy the file with dd. This creates an exact bit-by-bit copy of the file. So breakdown. dd, this is the disk duplication utility. If equals demo.txt is the input file. Off equals demo copy.txt is the output file that will be created. Verify the copy with ls, use the else switch, demo**. We can now see both files. Now compare the files. Type diff demo.txt, demo copy.txt. The diff command compares two files. If nothing is displayed, that's actually good news. It means the files are identical. So this is a more practical dd example. When security professionals perform forensic investigations, they normally use dd to image an entire storage device. This command creates an exact image of an entire USB drive. So if equals dev sdb, this is the source drive. Off root flash copy.image, this is the image file being created. bs equals 4096, this uses 4 kilobyte blocks to improve performance. And conv equals no error, this continues copying even if read errors occur. I'm not going to run this because it creates an image that's the same size as the entire drive. On a large USB or hard drive, that can consume many gigabytes of storage. Always double check if your if equals and off equals values before pressing enter. If you accidentally reverse them, dd can overwrite the wrong drive and permanently destroy data. That's why it's sometimes jokingly named Disk Destroyer. So key takeaways. tar combines multiple files into one archive. Gzip is the most common Linux compression format. bzip2 compresses better but is slower. Compress is older and produces larger files. And dd creates exact bit-by-bit copies of storage devices, making it invaluable for forensic investigations and data recovery. I hope you enjoyed this video. I'm CyberEd, and I will see you in the next one. Peace.